Welcome back, aviation enthusiasts and fellow aircraft builders. This is part 2 of my 10 scratch building concepts and recommendations video series. In the last video, we talked about, why you should or shouldn't scratch build an airplane, and what are your production capabilities, and then I gave you a little bit of information about myself. So we're going to start this video off with the number 3 concept and recommendation for scratch building an airplane, and that is you need to develop a project schedule that works for your lifestyle. Over the years, I've read countless sources of information that says that you have to spend at least 20 hours a week working on your plane, and that you have to do something every single day. If you don't do something every single day, even if it's going out for 5 minutes and setting a few rivets, that you're just never going to get it done. I totally disagree with that. I think that you have to figure out what works for your lifestyle. If you have a busy lifestyle, and I do, you're not going to be out here every single day setting rivets. You're just not going to feel like it sometimes. You've got other things to do. You've got a home improvement project, or maybe a repair that you've got to attend to, or you're leaving the house, or whatever. You're gone for 2 weeks, a family emergency, you name it. There's going to be times where you just can't stick to that schedule. And the problem with, even if you don't really come out and say that, well, but yeah, those go without saying, is that they have a tendency to cause you a lot of anxiety and stress when you are trying to keep, this tight schedule, or this strict schedule of airplane building, and it becomes a sore spot with you. It becomes a source of stress and a source of anxiety, rather than something that's just fun and great for you to do, and it's a good pastime and a good way to learn new tasks and enjoy your hobby. So I've changed my approach to building this aircraft, and the amount of time that I've spent per week or per day, all the time, depending on what I've got going on in my life. And so I would say don't sacrifice your family. Don't sacrifice time with your family. Definitely don't sacrifice your family, but don't sacrifice time with your family. You've got obligations at work. Make time for your kids. Make time for your spouse. Make time for significant others, friendships even. Don't ignore things, because if you lock yourself away into your project and spend all your time on your project, you're going to find that when you get done with it, there's not going to be anybody else to share it with when you get down, when you come out of that hole. So, develop a project schedule that works and fits for your lifestyle, but be flexible in that as well, and don't beat yourself up if you can't, come out to the shop or the garage every single day and do something. I ran into that pitfall early on where I was like, I really got to get out to the shop. I didn't do something today, and everybody told me that if you don't do something every day, you're never going to finish. That's nonsense. Just relax about it, have fun. An important part is having fun and enjoying the process without stressing out about it. Should not cause you a lot of stress. There are things in this project that will cause you stress, but that should not be one of them. So keep that in mind. Number 4, staying organized is key. Okay, staying organized. This project is huge. Even though we're only building I'm only building a small 2-seat aircraft that is a short range and low power and all that other stuff. This is a monumental undertaking. When you add the fact that we're scratch building a plane like this, it's even more monumental. There are hundreds of parts in this plane, if not thousands of parts in these planes. There's thousands of rivets that need to be set. Everything's got to go together relatively the correct way in order to have a finished flying plane. So staying organized is a key. What works for me is a spreadsheet, and I use Google Sheets online. So as long as I've got an internet or a data connection on my phone, I can access Google Sheets. I can enter data into there. I can enter the hours I've spent. I can enter the parts that I've finished, or the assemblies that I've worked on, or whatever. I can insert notes here and there. I can do lots of things. A spreadsheet application works great for me. There are a lot of other options out there for you. There are software packages you can buy. You can use a spiral bound notebook and a pencil if you'd like. You can use a hard copy spreadsheet style ledger if you want to. There's a number of ways to do things. Some people like the software packages, or the kit program, software programs out there, or the online programs. I found what works best for me is a very detailed spreadsheet that I can keep track of all kinds of different things on, and I'll post a link to that in the comments below. But anyway, using that spreadsheet in addition to taking detailed photographs and shooting videos for you guys. Um, you know, I stay organized by maintaining my blog online and in concert with my detailed spreadsheet. I can go back into my spreadsheet and look up anything that I need to know. If I made a part, I can easily find it in my spreadsheet the way that I've created it. If I need to know when I made that part or how much time I spent on that part, I can easily go back and look that information up, and it keeps a running total of things. Furthermore, in order to stay organized, you need to label your parts. Now, for a part like this, it's very obvious what this is. This is the nose rib and the main wing. There's 6 of these on each side. It's very obvious what this part is. I don't really need to label this. But there are plenty of parts in the plane that are just small channels, small angles, little tiny odds and ends that you have to build up for some of the structures. And a lot of them look very similar but have subtle differences to them. So if you don't label what those parts are and you go on a part making bender like I've done several times where for 3 months straight you're just manufacturing parts and you're not putting anything together, you tend to accumulate boxes of parts that you've put together. If you don't label them and you don't keep track of where those are, you're not going to be able to find them. The spreadsheet application that I created helps me at least know that I've made the part. Even if I can't seem to find it, I know that I just need to keep looking. But you have to label the part as well, so that when you're digging through a box of parts that all look the same, which one is it? Is it this one or the other one? These things are only a couple millimeters difference between the two of them. Which one's which? Well, I just write right on them with a Sharpie what the part number is. And sometimes I label it with the actual part name, so this would be, nose rib. But, so if it's, the flaperon spar angle, well, that looks like half a dozen other parts in the plane. If I've written on it, it's the, flaperon spar angle, then I know exactly what it is and I'll put the part number on it as well. So those things are key. It seems silly and probably self-explanatory, but there are times when I didn't label a part and I didn't know what it was and I made it all over again because I'd forgotten that I made it the first time. You would think that that would never happen. You would think that that's just not possible. You're only making 800 or 900 parts or whatever. You would think it's just not possible to forget that you've already made a part. I guarantee it's possible because I've done it, and I've only done it in the last 9 months. I mean, I've been working on this for 9 months, and that's how long I've done it. So label your parts, keep a detailed log of some kind, whatever works for you, and you'll be very successful. Number 5, don't buy all of your tools before you get started. Before you buy or build a new tool, carefully consider what you need it for. Obviously, if you're building a metal airplane, you have to have a bending brake. There's just no way around it. But you can't just run down to Harbor Freight and buy their 3-foot bending brake and expect that to work. In the STOL CH750, the longest bend that you need to make outside of a couple of skins are 8.5 feet long. The rear, the horizontal stabilizer and elevator spars are like 8 feet 5 3/4 inches long. If you build or buy an 8-foot bending brake or a 6-foot bending brake, you're not going to be able to fabricate those parts. So carefully go through the plans to determine, and this is another reason why creating a very detailed spreadsheet of parts and things like that is going back to the organizational standpoint. If you keep a very detailed spreadsheet of parts, to use as checklists in your builder log, you're going to have a lot of kind of innate knowledge as to what is all going into that airplane and how big the parts are that you need to make, and what thicknesses you need to bend and all that other stuff. Going into building up tooling or buying tools for that, you're already going to have that foundation of knowledge, and you're going to be able to make tools accordingly. When I first started this project, when I first started plans building, was back actually in 2011. I had decided at that point that I was going to start plans building. I started making some form blocks and I started making some ribs. At the time, I had incorrectly assumed that the CH750 was, in all ways that mattered, I thought that it was identical to the CH601XL that I previously thought I was going to build. Well, following advice from other builders, it was said that you only needed a 4-foot bending brake to do all of your bends in that airplane. Within reason, there's a couple exceptions to that, but I don't want to get into that. But the STOL CH750, however, totally different airplane. Totally different airplane. Even though it's designed by Zenith, it's all aluminum, it's 2 seats, it takes 100 horsepower. totally different airplane, requires an 8.5 foot bending brake. I still then again, so I built a 4 foot bending brake thinking it would do the whole airplane. I was wrong. Ended up taking a multi-year break from building, got started back again in July of 2015, so last year. At that point, had followed some other advice again for a CH601 or a 601XL. Again, thought, then I found out, he built an 8 foot brake and that does all the bends in the airplane. Doesn't do a 750 though, so I built an 8 foot brake. Couldn't bend all but 3 pieces in my airplane on that. Fortunately, I found a friend over the course of last year while I started building this. I was about 150 hours into my build. Met a new friend who has a machine shop and some other things. He's building a 701, and he had a lot of the fabrication tools that I didn't have, and so I was able to, after becoming friends with him, I was able to work on my plane. So I was able to bend those 3 spars without any problem. But if I hadn't met him, I wouldn't know that. But it brings me back to my point about, don't buy all your tools at once. Don't run out and spend $4,000 on tools, because I guarantee you about half of them are going to be useless by the time you get around to needing them. Although I did need to build a bending brake, I didn't need to then build a third one to accommodate those 8.5 foot spars, because I met somebody that had a brake and I was able to use it. So you may come across people. You're going to network with people as you build. You're going to meet new friends. You're going to network with EAA members. You're going to network with fellow builders, or just people in your neighborhood. You might meet a neighbor down the street that works on a machine shop, and they might have a bending brake that you can come in and use, and pay them a $25 shop fee. You just never know. So don't go out and buy everything all at once. Really strategically purchase things as you really need them. You can do a lot of work on this airplane with some woodworking tools. Just building up all your form blocks. I've got form blocks and cutting blocks here. This is a form block for the nose rib. This is a cutting template for the same nose rib. You can do a lot with a bandsaw, a woodworking bandsaw, a belt sander and a spindle sander, and maybe a drill press. You can get a lot done before you really need to start worrying about bending metal with a bending brake. So, do it gradually, carefully examine the blueprints to figure out what you need capacity-wise for these tools. Likewise, you're going to need metal cutting capabilities. If you're going to weld, you need a welder. What kind of welder do you need? Do you know what all kinds of welds do you need that are going to go into this airplane? In this airplane, the STOL CH750, you have to weld chrome moly steel, 4130 chrome moly steel tubing, a few other little odds and ends that like bolts and things like that you weld to fixtures and stuff. And then the other welding is the aluminum fuel tanks. Well, if you're going to weld thin wall aluminum fuel tanks, you need a TIG welder that welds AC on AC current with high frequency start. There are very few hobby level machines in the world that can do that. I bought the AHP Alpha TIG after doing exhaustive research on welders. I almost purchased a TIG machine that wouldn't have done it, and it was because I didn't do enough research at the time. I held off on making the purchase. That machine was actually more money than this machine, but I held off on making the purchase to make sure that I'd done enough research, because I'd made mistakes with the bending brakes before and other tools, and finally really dialed in on the exact kind of capacity that I needed in a welder, and learned that this was the right machine for me at the price point that I wanted. There are much more expensive machines that would do the job as well, but I found this to be the most reasonable price for the capability that I needed. Furthermore, if you're going to buy a big air compressor or a big welder or something, you need to have 220 in your shop. 220 volt circuit. I can run this on 110, and it does everything in the airplane I need it to do on 110. Slightly shorter duty cycle, but my air compressor runs on 110. It's got enough capacity, so I don't need to run new electric service in my shop, or garage rather. But if you run right out and buy Lincoln Electric makes the best welder, and I can go out and buy this Lincoln 185 amp TIG machine. So now I got to wire 220 in the shop to run it. That may be money that you wasted if you don't need that capacity after you're done with the project. I wanted a hobby level welder that I could weld odds and ends here when the plane is done. I probably will build another airplane when I'm done with this one, so I'll need the welder for that. And I always have a project. I always like welding stuff and doing things like that. So do your research. It's critical that you do a research. It's hard to know when you've done enough research, but do a lot of research and you won't end up spending money, in error. Another thing I'd recommend about the tooling is if you don't have a drill press already, you can build this airplane without a drill press from scratch, but it would be really difficult. A drill press gives you much more precision and control and the ability to drill perfectly perpendicular to your workpiece and things like that over hand drilling. And furthermore, if you're going to buy a drill press, you don't already have one, I would recommend a floor standing model that gives you a lot more clearance between the drill chuck and the stand or the platform than a bench mount will give you. My bench mount 10-inch drill press has been great. It works fine. I've had it for many, many years. But looking back, I should have spent a little bit extra money and bought a floor standing model if I'd have known I was building an airplane when I bought my drill press. A little note about Harbor Freight tools. Harbor Freight, we all know, or most people know that Harbor Freight makes some very, very inexpensive tools. I don't want to say cheap because that makes them sound like they're poor quality. Some of their tools are poor quality. They don't have very good manufacturing fit and finish. Tolerances are terrible on some of them. They're just not professional grade tools. They're made to sell at the price point that they sell, and they sell a lot of tools that way. But you can find some really good tools at Harbor Freight for the project that we're doing. You're not running a production shop. You're not manufacturing airplanes over and over and over. You're not, running a metal fabrication shop or a woodworking shop or something like that. You're just running a home level hobby shop if that's what you're doing. There are plenty of tools at Harbor Freight that will fit that mission just fine. I have their heavy duty right angle die grinder, electric one for some metal fabrication. I have one of their bench grinders. I have tons of their hand tools. Some of their welding tools. I have the welding table from them. I use a lot of their locking clamps and things like that. I've got dead blow mallets. I've got other woodworking clamps that I use for clamping pieces. Those are all fine and very inexpensive. So Harbor Freight allows you to buy certain tools that don't need to be expensive, high quality tools at a very reasonable price. I use their roller stand for holding up wing spars and stuff at the drill press. I mean, that's all fine. It doesn't need to be professional grade stuff. So don't discount Harbor Freight from your list of tools, even though you're building an airplane, which needs to be a relatively precision final product. There's a lot of stuff at Harbor Freight that you can use just fine. So consider that. Number 6, we talked about my welder a little bit. I mentioned it in another video. I highly recommend, if you're willing to take on the responsibility of learning to weld for an aircraft, that you do so. This welding capability gives you so many more options in your shop for making special fixtures. A bending brake, for example, you can build a much nicer bending brake if you have a welder than you can just bolt a few things together. Holding fixtures, bending fixtures, riveting fixtures, you name it, drilling jigs, centering jigs. If you have a welder in your shop and you know how to use it, there's nothing you can't do. I mean, it gives you so much more capability for this project, and especially if you have it early on. So if you don't know how to weld, and you are fairly certain that you want to learn how to weld, I would recommend getting your welder before you even start your project and doing a lot of practice stuff. Practice by welding up a bending brake. Just make sure you build it to the right size you need. Weld up a riveting fixture, weld up a couple of bending fixtures. Things that that you're going to need. Weld up a stand for something. Practice welding, and build your tooling while you're doing it, and you'll just have so much more capability. And furthermore, by the time you get done doing all that, you'll have the capability to weld on your aircraft, weld the parts of your aircraft that need to be welded. But make no mistake, welding for an aircraft is a whole different animal than repairing a trailer hitch, or splicing two pieces of metal together for a shelf, or welding up a storage bracket for 2x4s. Welding on an aircraft is a big responsibility and requires a certain amount of skill and precision to be able to do properly to have an airworthy aircraft. So Make no mistake, it is not to be taken lightly. If you think that it's too daunting to learn to weld, or you're not sure if you want to learn to weld, or you're not sure if you're going to be able to weld by the time you get done with it, don't even bother. You're only going to save a few $1,000s by purchasing a welder and doing it yourself. Granted, it does give you a lot more capability when it comes to building up your special tools, so don't discount that. But it's a big responsibility to weld on an aircraft, even if you're the only one that's ever going to fly it. So that's the end of part 2. When I come back, I'm going to give you the final 4 recommendations and considerations for scratch building. Thanks for watching, and we'll see you soon.